In building science, and specifically in energy modeling and HERS ratings, we rely on basic algebra and geometry to calculate areas and volumes in modeled dwellings. This is the floor plan of a house. Although the drawing contains many details, notes, and symbols, once we strip away the noise, we can see that the home is fundamentally just a rectangle. To calculate the area of this floor, we multiply the length by the width, giving us area. The area of any rectangle is calculated by multiplying the length by the width. In this case, the home is 46.7 linear feet in length and 30 linear feet in width. Multiplied, this gives us 1,401 square feet. This home, however, is not a simple rectangle. There are additional sections that give the floor plan a more complex shape. By breaking the floor into smaller sections, we can see that it is actually composed of multiple rectangles. As before, we calculate the area of each rectangle by multiplying its length by its width. Once each individual area has been determined, we add them together to get the total area of this level. Many homes consist of various size rectangles and squares, and although they may seem complicated at first glance, the key is to break them down into smaller, manageable shapes. Sometimes it's easier to create a larger rectangle that covers the entire outline, including portions that are not part of the home, and then subtract out the smaller areas. This approach is especially helpful for irregular footprints. We have 4 rectangles: blue, yellow, green, and pink. A portion of the pink rectangle covers an area outside of the home. We simply deduct the 2-foot by 11-foot 2 area from the total, and by doing so, we arrive at the correct total of the home. Beyond rectangles and squares, homes also include triangles and trapezoids. When we move to section views on the plans, we still see many rectangles, but we also see triangular shapes in the gables of attics and upper floors. To calculate the area of a triangle, we must multiply the height by the base width and then multiply that product by 1/2. In this example, the gable end of the attic forms a triangle. By measuring from the attic floor to the ridge, which is the height, and measuring the width of the attic, which is the base, we can determine the area of the gable. This gable is 15 feet high by 30 feet wide. 15 times 30 times 0.5 equals 225 square feet. The lower floor is 9 foot 2 tall by 30 feet wide. That gives us 276 square feet for that wall. The home is 40 feet long, so if you multiply the 225 square feet of gable by 40, you get 9,000 cubic feet. Similarly, you multiply the wall, 276 square feet, by 40 linear feet, and you get 11,040 cubic feet. Added together, the entire home is 20,040 cubic feet. Trapezoids often appear in the footprint of bays. To calculate the area of a trapezoid, we add base 1 and base 2. Multiply that sum by the height, and then multiply by 1/2. You can think of a trapezoid as a rectangle with 2 triangles attached. In this case, the bay projects 2 feet out, and the width of base 1 is 8.5 linear feet. Base 2 is 4.5 linear feet. 4.5 linear feet plus 8 linear feet times 2 times 0.5 means that this bay has a square foot of 13 square feet for floor area. Multiplied by the ceiling height of 9 linear feet, the bay has 117 cubic feet of volume. Trapezoids can also appear in attic walls with partial flat ceilings. If the top floor has both flat and sloped ceilings, those elements together can create a trapezoid. This is a section view of a walk-in closet. you look further up on the plans, you can see in plan view, it's a small section and the dotted lines refer to a sloped ceiling. If you scroll in on this, you can see that it's 10'8" to the center of the walls, which means it's actually 11.2 linear feet outside to outside, and that the wall height is 5'2". With this information, we know that 5.2 linear feet taken from a total of 8 linear feet, which is the ceiling, will yield a rise or height of a trapezoid, this trapezoid, by 2.6 linear feet. We just told you that the base was 11.2 linear feet. Base 2 is simply 2.6 linear feet deducted from 11.2 plus an additional 2.6 linear feet deducted will give us 5.8 linear feet for base 2. Therefore, after the equation, base 1 plus base 2 times the height times 0.5, the area of this trapezoidal part of this wall is 21.8 square feet. The rectangular portion of the wall is 5.2 linear feet tall, as we saw above, and it's still 11.2 linear feet wide. Multiplied, that gives us 57.2 square feet. Added together, this trapezoid plus this rectangle equals 79 square feet. The profile of this walk-in closet is 79 square feet. And if you noticed above, the walk-in closet is actually 8 linear feet long. Therefore, the 79 square foot wall, which is represented by the rectangle plus the trapezoid, multiplied by 8 linear feet, means that the walk-in closet is 632 cubic feet. That is 632 cubic feet of volume, which will be added to the rest of the house. It's important to understand these basic concepts. The next step is to use software to assist in these measurements, such as Foxit PDF Reader or perhaps a more powerful Bluebeam. These fundamentals provide the foundation for understanding the more complex shapes you will encounter in energy modeling and HERS ratings.